Okay, we have a coin that is rolling with a certain angular speed, um, and it accelerates and slows to rest at 1.9 meters radians per second squared with a final angular speed of 0. Now, just like a motion problem, we would set this up with our initial speed and position, acceleration and time, final angular speed, and final position. Ultimately, they're asking for a distance, so this final angular displacement is going to help us find how far it actually went. So here they're asking for how far does the coin travel. So we're looking for a distance, d or x, which means we are looking for a change in angular displacement. And they want us to plot a omega versus time graph and acceleration versus time graph, noting the value of the y-intercept. So with this, if we're looking for our displacement or our angular displacement, we need to find an expression that relates the initial velocity, the final velocity, and acceleration together. Right? Going back to our motion equations, that's going to be the initial angular velocity squared plus 2 times the angular acceleration times the angular displacement will equal our final angular velocity squared. So if our final velocity is 0 squared minus the initial 18 radians per second squared, that will equal 2 times negative 1.9 radians per second squared times delta theta. Now, if you're wondering where the negative came from, just similar to motion, if the object is moving one way and it is decreasing velocity, the acceleration has to be moving the other way. So in solving for theta, we would divide both sides by 2 times negative 1.9 radians per second squared, and theta will equal 85.26 radians. So that tells us how far we traveled in terms of angular displacement. Now, going back to the idea of linear values equaling angular values times the radius, again, if you don't remember the circumference, you have a linear translational value equals an angular value times the radius. So our distance traveled will equal the angle in terms of radians times the radius. So here, our final distance traveled is going to be 85.26 radians times the radius, which in this case is 0.012 meters. They gave us the diameter at the start of the problem, so we're going to end up with a distance of 1.2 meters traveled. Okay, to find the final angulars, to find the time it takes to come to rest, so I know where to draw this on the velocity versus time graph. We have 0 is equal to 18 radians per second minus 1.9 radians per second squared times t. Ultimately, when I solve for t, I get about 9.547, if you want to be specific, seconds. So, very similar to an object that is traveling and slowing down, your angular velocity will start at 18 radians per second and go to 0 in 9.5 seconds, and your